So Algebra 2 students, Mr. Messner here. We're going to talk about exponential growth and decay, a new type of function that we're going to investigate. For day one, we're primarily going to be looking at functions that look like this. And just to have a good understanding of what these functions look like, I'm going to go into Desmos. Your test for this unit will be a project, and you'll be using Desmos to kind of help you with the project. So you may use Desmos when you're doing your homework because you're going to be using it for your project. And the first one we have right here is just 4 to the x. So let's just look at 4 to the x. I got to type in 4 and then 2the. So I'm going to use the caret button. Shift 6 brings up the caret. It won't show up when you type it into the equation. You just shift 6 and it goes up, and then you do 4 to the x. And you can see this is a great example of an exponential function. Okay, it grows really quickly, and then on the other side it goes really close to 0. And let's just investigate what happens when we put numbers in front of it. So the key for exponential functions is that you have this a times this kind of value to the x. And this is the value at which you grow things or decay things. So notice what happens when I change this value. Now look, this 2, we call this a is initial value. How much you start out with, how much money you start out with. So I start out with $2 at year 0. This is what I start out with. And then I grow it at 4 times, maybe a year or per day or whatever. And when you change this number, you change the growth. So see how my curve is changing. I'm not growing as fast when I have 2 to the x compared to 4 to the x. 4 to the x growing very quickly. Versus 2 to the x, it'll get a little bit shallower. From Desmos, you can kind of click on the graph to see certain points. You can see after 1 year, you're doubling your initial amount. You get to 4. After 2 years, you would double your amount again and get to 8. So you can kind of click through with that. Now notice how if I change this to 1, I'm not increasing the amount at all. I'm just multiplying it by 1 a year, so I'm just getting $2 every year. But if I change this to a fraction, say 0.6, some decimal, all of a sudden I'm decaying my amount. I'm decreasing my amount. I start with 2, but then my amount decreases because I'm multiplying it by a percentage. Now this is where 1 plus r comes into effect, and we talk about the rates at which we grow and decay. And we'll get into that more. For now, let's just kind of graph and understand that when you're plugging in values that are decimals, you're going to be decaying, and our numbers, you're going to be growing. So growth versus decay. 5 versus 0.5. Again, you change this number. All it does is change the starting amount. So I'm starting at 5 here. Change this to 10. I start at 10. But then I am decaying. I'm reducing by 50%, or I'm multiplying by 0.5 this number every time. So I get half of it, which is 5, after 1 year. And then after 2 years, I'll have half of that. So I'd get 2.5 after 2 years. Okay? So let's get into the homework. We'll look at 4 to the x. Now, what's important, and don't love these examples, there's no really initial value. You start at 1, and you're growing by 4 times. We can have this also look like y equals a times b to the x. If b is greater than 1, we are growing. If b is between 0 and 1, if it's a fraction, if it's a decimal, it's decaying. So 4 to the x looks like this. If you want to fill out a table, you can. To pull up a table, you can just type in table, and if you want to, you can say this is y sub 1, 4 to the x sub 1. It's not, didn't work. You can just go 4 to the x. I think that works. No? Not sure how to pull up that table. Instead, let's just graph y equals 4 to the x and look at some points. Initial value 1. There we go. There's that initial value. So I got 0, 1. You can go to the left a couple points. Negative 1, 0.25, because I'm dividing by 4. We'll go to negative 2, divide a fourth by fourth, and I'm going to get 1/16. 0.063. If you go to 1, you'd see you'd multiply that 1 by 4, you get 4. You go to 2, you'd multiply this 4 by 4, you get 16. $2.16. And so things you realize is like to get to the next value, you would multiply by b. To get the previous value, you would divide by b. And you have your shape of your graph. You're allowed to plug in any x into this. However, you don't get any negative values. You don't even get 0. Your y values start at 0 and they go up to positive infinity. You won't even get 0, so we're not going to include 0. We're just going to go and say we're getting close to 0 and we're going to infinity. All positive y's will be produced. Where do we cross the x-axis? We don't. Where do we cross the y-axis at a, our initial value? Here, 3/4 to the x. Again, we don't have an initial value. The initial value is 1. But we see since b is between 0 and 1, we are talking about a decay. We're multiplying by 3/4. So we start at 1. For 0, after 1 year, we're going to be at 3/4. 0.75. After 2, we'll be 3/4 of that. 0.563, which is 3/4 times 3/4, etc., etc. Don't think the table is super important. It's more just the understanding of the shape. Understanding that this is a decay versus this is a growth. Understanding that your initial value is 1 because you have a 1 here. That's your A. That's your B. Your growth rate is a decimal, which is why you're going to decay. If you go to -1, we could find that point. Let's just do -1, 0, and 1. 0 is 1, 1 is 3/4. I'm going to divide by 3/4, which is multiplying by 4/3. So I'm going to see that I'm going to get 4/3 if I go to -1. 4/3. And then divide that by 3/4, which is multiplying by 4/3. I get 16/9 if I go to -2. This would be 16/9. Just the idea of the shape is really all that's needed versus specific points. Again, you can plug in any value into these exponential functions, but you're only going to get positive y's. You could flip things and get all negative y's, but that's not really applicable in the real world. We're going to be talking about starting with values and increasing them or decreasing them. The y-intercept, again, is at 1, which is A. All right, now let's talk about end behavior. It's on your phone. As x's go to negative infinity, as our x's go to negative infinity, my y's are going to 0 in this case. We're getting closer and closer to 0. As x's go to positive infinity, my y's are growing up to positive infinity. It's kind of like your arms. Which direction are your arms? Well, for exponential functions, we're no longer talking about straight up and down or like this or this. It's this or this. This would be a growth. I think this looks like a growth to you. This would be a decay. I think that looks like a decay for you. So like 0, infinity, infinity, 0. So here, for this one, let me make sure this works out right. Yeah, that works. Okay. So for this one, we got arms like that, which means as I go to the left, I'm going up. As I go to the right, I'm going to 0. As I go to the left, I'm going up. As I go to the right, I'm going to 0. We are not approaching to, we're not getting to 0, we're approaching 0. So y equals 0, we call an asymptote. Okay, we transition from a times b to the x to a times 1 plus a rate to the x. This is when we talk about percentages, percent growths. In real world, say bank accounts, we don't like double our money every year, starting with $5 and double it every year. Instead, we grow by 5%. So all of a sudden, it's not times 2 to the x, it's times 1.05 or 1.05 times growth every year. So we switch b and b becomes 1 plus r. And this r is our percent growth or our percent decay. If I add r, if r is positive, I'm growing still, but by a certain percent. This would be 5%. If I subtract r, I'm going to be multiplying my initial value by 0.95, so we have a decay. I'd be decreasing by 5% every time. So this is important for understanding for the next lesson when we're talking about real-world situations, that this b value you get is 1 plus r. If r is negative, it's a decay, and it'd turn into 1 minus r. If r is positive, it's a growth, so it's 1 plus r. So here, all we're doing for these 4 problems is setting b equal to 1 plus r, and we just subtract 1 to get r. 0.4 minus 1, you could do it in a calculator, you could do it in Desmos. 0.4 minus 1 is negative 0.6. Okay, since r is negative, since b is a decimal, we're decaying. R is negative 0.6, or we're going to use 1 minus 0.6 as our equation. To turn a decimal into a percentage, we just multiply by 100 or move the decimal place over 2. So this would be a 60% decay. We start with 2, we would decrease it by 60% every year. Okay? So all of the other ones, like we're starting with 2, and if you wanted to graph this, you could see we're decaying. But we're trying to figure out like by what percent are we growing or decaying. Here you can see b is above 1, so we are back to being a growth. We would say b equals 1 plus r. This is for this example. I probably should move them over, but whatever. Subtract 1, and you get r is 0.53. That means I'm growing by 53% a year. Move the decimal place over twice. Next situation, this b value is less than 1. We are going to decrease in the amount that we have every year. B equals 1 plus r, subtract 1. 0.9 minus 1 is negative 0.1. So that means we are decreasing by 10% every year. And the last one, 1.75, 1 plus r, subtract 1, r is 0.75, or we are growing by 75% every year. Okay, good one to do is like the 50% growth. If I change this to 1.5, just to show you. If I have 1.5 and I started with 2, I'm increasing by 50%. Well, 50% of 2 is 1. So if I increase by 50% after 1 year, I'm going to get to 3. There we go. 50% of 3 is 1.5. If I go to the next year, I'm going to be at 4.5 because that's how much I'm going to increase. So after 2 years, I'm going to be at 4.5. Okay? What we're going to do in the future is like figure out, hey, after 5 years, how much do we have? Oh, I have $15.188 dollars or amounts or something like that. Or we can say, how long will it take if we're growing at 50% to turn my money into $18? Okay, right there, after 5.419 days or years or whatever, I'll have $18. Okay? All right, so again, we can think of this as an initial times a rate or an amount that we are multiplying our values by every year, every day. That can turn into 1 plus a percentage. B is equal to 1 plus r. We're starting with 2. Since this is less than 1, we are decaying. You could graph to see it. What is the factor at which we're decaying? We could say B is equal to 0.3, or 0.3 equals 1 plus r, subtract 1, r equals negative 0.7. We are decreasing by 70% a year. Since it's a decay, we are decreasing in our amount. And if you graph this, you'd be able to see you would be losing 70% every single year. Here, I'm starting with 5. When time is 0, I have $5. 1.8 to the 0 is 1, so I just have 5. Which means I'm growing because this is bigger than 1. What is my factor? I can say B is 1.8, or I can find R and find that I'm growing by 80% a year. Since I'm growing, supposed to label the y-intercept. The y-intercept is our initial amount at time 0. Y-intercept, our initial amount is 5 at time 0. As I go to the left, I'm going up. As I go to the right, I'm going to be going towards 0. As I go to the left, I'm going up where your arm's pointed. As I go to the right, I'm going to 0. As I go to the left, I'm going to 0. As I go to the right, I'm going up towards positive infinity. By asymptote, we are approaching, but we'll never get to y equals 0. The last question we have is to get the equation of this graph. And it might seem intimidating, but it's really no big deal if we go back to our table and understand something. Our initial value always occurs at time 0. So we can get A just by looking at our y-intercept. So let's write that down. Our y-intercept is A. And we're looking at A times B to the x. So my y-intercept is 0.25. Cool. Now I got to figure out what B is. Well, look at what we noticed in our table. To get to the next number from 0 to 1, what did I multiply this number by to get that, 4. So B is like the multiplier. From 4 to 16, what did I do? I multiplied by 4. From 0.25 to 1, what did I do? I can multiply by 4. Or 1 to 0.25, I divide by 4. I like to always say like we're multiplying versus dividing. So we start at a value. To get to the next value, we will multiply by B. Here, to get from 4/3 to 1, I multiply by 3/4. To get from 1 to 3/4, I multiply by 3/4. So to get this value B, we could take two sequential numbers and divide them to figure out what are the numbers that multiply. For example, there's two ways to get it. Here's 2, here's 3, so there's two sequential numbers giving me y values of 6.75 and 2.25. I'm going to take those numbers and divide them. 6.75 divided by 2.25. And I can see to get from this value to that value, I multiply by 3. Well, let's look at another set of numbers from negative 0.083, which probably should be a decimal because it probably isn't going to work out nicely. So I believe that's 1/16, 1/8, 1/12. Yeah, it's 1/12. So if I take 0.25 and divide it by 1/12, I should get that number 3 again. Now I'm a little bit close to 3 because I'm using a decimal, or if you use 0.25 and divide it by 0.083, you're going to see that since we're like rounding this number, that we're not going to get exactly 3. So this is why these two numbers are probably easier to use, but you can kind of see how it does work. You take this number, multiply it by 3, and you get that number. Two sequential numbers, what do you multiply by to get the next number? And that's B. Okay, so B is equal to like your next y value divided by your previous y value. Whether it's your y at time 3 divided by your y at 1, your y at 2, or your y at 2 divided by 1, or you can take your y at 0 and divide it by your y at -1. Don't worry about the notation, just like divide the next y by the previous y. How about that? What you can't do, though, is go from this value to that value. You would have to say, like, 0.25 times what number twice equals 2.25. This is actually something you can solve. Watch. 2.25 divided by 0.25, we just solved equations like this, is 9. Square root 9 to get rid of the square, and you can see 3. All right? So maybe you could set up an equation as well where it's like your next number equals your previous number times what? B. Anyways, that might be complicated, so stick to this. All right, so that's your equation. If you wanted to check, you could, and that's the homework. 0.25 times 3 to the x. Here's my 0.25. Here is my 2.25. And here is my 3. 6.75. Just like I see here. All right, thanks.